Hello viewers, welcome back to another episode of Ecovalorum's lesson. If you get this video, don't forget to like, share, subscribe and then click on the notification bell. Okay, so today our lesson, quickly, we are going through further calculus. Calculus we know has been a delicate part of mathematics and then economics. Now we are tackling an aspect of further calculus known as integration by part. We know from our learning that integration is the reverse, is the opposite of differentiation. By that we mean that after differentiating a function, you can get that function that you actually differentiated back by integrating it. But today we are saying our lesson is about when we are having complex functions. How are we going to solve them? How are we going to integrate complex functions? So I'm going to take you through the steps that you go through to come out with a term or with an equation that will help you to integrate complex functions by part. So now the emphasis is on integration, but it is on integration by part. Now we are saying y is a function, and then y is a function of u and then v, and then u and v are in terms of x. Okay, so now we are saying that to differentiate y with respect to x, it is the same as differentiation of uv with respect to x. Good. So now dy dx is the same as duv dx. So at this point, duv dx is equal to, by product rule, you know from our studies in differentiation, that when you have two functions which are multiplying and then you want to find their differentiation, if you want to differentiate two functions, two product functions, what you have to do is first you keep one function and then you differentiate the other one with respect to the variable, plus you keep another function and then you differentiate its neighbor with respect to the variable. So this is our approach. So the integration by part was actually built with the help of the product rule of what? Differentiation. So here we are saying duv with respect to dx is equal to, here we are keeping u. So we are keeping u and then we are differentiating v with respect to x. So that is why we are getting u dv over dx, plus here we are keeping v and then we are differentiating u with respect to what? X, and that is giving us v du over dx. Now after this we multiply both sides. Now this is a fractional equation. We want to do away with the fractional equation so that we will get a simple linear equation. To get this, multiply each term of the equation by dx. So we take this, we multiply it by dx, this term also multiply by dx, and then this term also multiply by dx. Now you get to know that the dx will cancel each other, and that we are coming to have duv is equal to u dv plus v du. Now we introduce the integral of both sides. We are dealing with integration, so now we integrate each term of the function. So we pick duv, we integrate it. We take u dv, we integrate it, and then we pick v du, and then we also what? Integrate it. So now the differential of uv. So if you integrate the differential of uv, you are coming to get the uv. Okay, so the differential, the integration of duv will give us uv, and this is equal to the integral of u dv plus the integral of v du. So now our function becomes uv. What we did here was to transpose v du to the other side of the equation, because we want to make u dv, or the integral of u dv, the subject. So that is why we sent v du to the other side of the equation so that we can make u dv the subject. So now we are having uv minus the integral of v du is equal to the integral of u dv. So now this term can be rewritten as the integral of u dv is equal to uv minus the integral of v du. Thank you.